All right, this is problem 6. And again, we were given u. We have a slightly more challenging substitution. We'll see in a second. But like I mentioned in the previous problem, look, they're choosing the square root to choose a u from. It's going to be the case a lot of the time, I think majority of time. So we're given our u. But we have an x squared in the numerator. So how are we going to get that in terms of u? We're going to find out now. But first, let's compute our simple u du. Let me just get rid of that. Oops, there we go. Du. It's just going to be dx. So we're going to cancel our dx's like that, because the derivative of x is 1 and the derivative of 8 is 0. So we're just left with 1 times dx, and that's just dx. So we're just going to cancel our dx's right now. And let's rewrite our integral. So right now we have this x squared, so I'm not going to write that. But we know that this is square root of u. This is du. That's all we have right now. But we need to get that numerator. We want to rewrite. We want to find what x would be in terms of u. So we're going to subtract an 8 over. U minus 8 equals x. So now where we see an x and that we haven't already substituted, we're going to plug it in. So we have u minus 8 is x. But wait, this is x squared. So we're going to parentheses and square it. And that is our integral du. Now we actually have to evaluate it. It's going to be a little bit more difficult, but we're able to do that by just factoring out the square in the numerator. So let's start with that. That's going to be u squared minus 8u minus 8u. It's going to be minus 16u. And then plus 64 over square root of u. And I like to write my square root of u's as u to the 1/2. So I'm going to erase this and have u to the 1/2. Now I'm going to split up the integral, or split up the fraction per se. And we're going to have the integral of u squared over u 1/2 minus 16u u 1/2 plus 64 u 1/2 du. And now we just have to evaluate each part. So firstly, let's get these u's up to snuff. So we're going to do the exponent rule. If we move this up, we have to subtract it. So we have 4 over 2 minus 1 over 2 is 3 over 2. So u 3 over 2. 1 minus 1/2 is positive 1/2. So minus 16u 1/2. And then it's just going to be plus 64x to the negative 1/2. Integral and our du. And now we just got to evaluate it. So now we're going to add 1 to the exponent of either u. Sorry about that. So we got plus 2 over 2. That's u 5 over 2. And we have to multiply by the reciprocal. So it's going to be 2 over 5 to the 5 halves power. We're going to add 1 over here. So 2 over 2. It's going to be 3 over 2. So minus, so we're going to have the power is going to be 3 over 2. We have to multiply by 2. We're going to do on the side here. 2 over 3 times 16. That's 32 over 3. So minus 32 over 3. That's that part. Now we got to add 1 to here. And that's just going to be 1/2. And then so 1/2, the reciprocal of 1/2 is just 2 times 64 equals 128. So we have plus 128 u to the 1/2 power. And then that's going to be an indefinite integral plus c. That is our evaluation and done for part 1. That's our integral setup for part 1 as well. I'll circle that. So part 1 completely done. But now we have to back substitute with the x's. So everywhere we see a u, you put back our u in terms of x. So we have u equals x plus 8. So we put an x plus 8 everywhere we see u. So let's write that out. 2 x plus 8, 5 over 2 over 5 minus 32 x plus 8, 3 over 2 divided by 3 plus 128 x plus 8 to the power of 1/2 plus c because it's indefinite, and that is our final integral.